Hi, welcome back. In this tutorial, I'm going to discuss about another good example of programming where we can use a stack data structure to solve a particular problem. Here we are going to develop a program where the program is going to check whether the input expression is having its brackets well formed or not. Often in mathematical expression, we have brackets or parentheses in order to increase the precedence of certain operations. Say, for example, we have something like this: a plus b times c, and we want to evaluate a plus b first. We'll put a bracket there, we'll put a parenthesis there, and we can go ahead and have curly braces or something like this, square brackets as well. Now this expression is good as long as, or as far as the brackets are concerned, they are well formed. We are having proper matching of opening and closing brackets. Now this kind of expression is going to be the input for our program, and the program is going to check whether the brackets are well formed or not. And if something like this is given there as input, then the program is going to say that it's wrong. This is obviously not well formed, and the program is going to flag error for this kind of input. Or it may have something like this as well. So we have a plus b and divided by c, and we have a closing square bracket there which is having a opening curly brace, so for its corresponding opener. So it's wrong. Actually the program is going to detect that this expression is not well formed and it's a bad expression. So for this purpose, what we need is a stack. We will keep this expression in a character array, and we will go ahead and scan the whole expression in our program, and we will decide whether it's a well-formed expression with the brackets or not. And for this purpose, as I said, we will use a stack. And the idea is that whenever you are getting an opening bracket in the expression, while scanning the expression from left to right, push the bracket into the stack. And then whenever you are getting a closing bracket, check whether the top of the stack contains the opening match for this closing bracket or not. Now if you just look carefully into this expression, into any expression, you can see that the last bracket that you are having as the opening bracket will be closed first. That means, say we are having the last bracket, this is the parenthesis that is lastly opened in the expression, and that is closed first. Similarly here we have this last opener that is closed first. So this is the key behind the idea of developing the algorithm for this purpose. Okay, so while scanning the expression from left to right, what we will do, if we encounter an opening bracket, we'll push it into the stack. Whenever we are getting a closing bracket, we'll check whether the top of the stack contains the opening match or not. If the top of the stack indeed contains the opening match for this closing bracket, we will pop the stack. That's okay, and we will go forward with the scanning, and we'll do the same thing again. That means if we get another closing bracket, we will check whether the top of the stack contains the same opener or not, or opening match for this closing bracket or not. Now if we get a closing bracket and the stack is empty, obviously it's an error. Say something like this: if we have this expression as the input, we'll get this closing bracket at the very beginning, and obviously the stack is going to be empty because we have not pushed anything into the stack. So this is an error condition. So the case is this: if we get a closing bracket, we'll check the top of the stack. If the top of the stack contains corresponding opening match, it's okay, we'll pop the stack. If the top of the stack doesn't contain a corresponding opening match for this closing bracket, then obviously it's an error. We'll pop the error and we'll stop the scanning. If we get a closing bracket and the stack is empty, obviously this is also error. Okay, let us take this another example. We have this expression here in an array, and obviously there is null at the end of the array, and each element is a character, and we have this stack there. We will be using this stack for the purpose. Now as far as our idea goes, we'll start scanning from the very beginning of the array, that means from the index number 0. So we get a square bracket, opening square bracket there, and our logic tells us that if we get opening brackets, we'll just push it into the stack. So we have this opening square bracket, we'll push it into the stack. Then we'll go ahead, we have this 2. Now we'll just ignore that. Then we have this star, we'll ignore that. We have this opening curly brace, and since this is an opening bracket, we'll push it into the stack. And then we have this opening parenthesis, we'll push it into the stack. Then we have 3, we'll ignore that. Minus, we'll ignore that. 1, we'll ignore that. And we have this closing bracket, closing parenthesis. Now as soon as we get this closing parenthesis, we'll check what the top of the stack contains. Now the top is right now here, so the top of the stack is the opening parenthesis. So the top of the stack is the opening match for this closing parenthesis, and we'll just pop this out. That means whenever the top matches with the closing bracket, then we just pop out, and then obviously the top will be decremented. As soon as we pop the stack, the top will be decremented, and top will be here right now. We'll move ahead, we get a slash, we'll ignore that. Any operator will be ignored. Then we get another opening parenthesis, so we'll push it into the stack, and then again we get 5 plus 7, all will be ignored. We'll move forward, and then we get this closing parenthesis. Again we get this closing parenthesis, we'll check whether what the top contains, and we see that the top is actually the opening parenthesis, so that will be popped again. So it will be popped again, and again the top will be decremented to this curly brace, and then again we'll move forward. We get this closing curly brace, and we see that the top of the stack contains the opening curly brace, so obviously they match. So we'll pop out this stack, and the closing opening curly brace will be popped out, so the top will be decremented to the next element, that means here. And then we get this minus, we'll ignore, we'll go ahead, and 4, we'll go ahead. Then we get this closing square bracket, and the stack top contains the opening square bracket. They match with each other, so we'll pop out the stack, and the stack will attain the underflow state. So the top is here right now, and we come to the end of the string, and we see that the stack is empty. Now while coming to the end of the string, the stack must be empty in order to be the expression is a good expression. And we say that for this example it happens so the input expression is good. Now encountering the end of the string, if we get something there in the stack, that means if the stack is not empty even when we come to the end of the input string, obviously there are some excess brackets, and that will actually flag the error. Okay, let us take this another example where the expression is not good. So we'll start again from the very beginning of this expression. 3 will be ignoring this, star will be ignored. Then we get an opening square bracket, it will be pushed into the stack, and then we get an opening parenthesis, we'll push it into the stack since they are opening brackets. Ignore 8, ignore plus, ignore 9, we get a closing parenthesis there, and obviously the top of the stack, which is right now here, contains the opening parenthesis. They match with each other, so we'll pop this out, and then we'll move forward. And when you pop, obviously the top is actually decreased, and the top is right now here. Then we'll move forward, we get this slash, we ignore. Then we get this opening parenthesis, again this will be pushed into the stack, and the top is going to be incremented, so the top is right now here. And then we get 9, ignore this, minus 2, then you get this closing parenthesis again, and you have the opening parenthesis, so the thing is same, they match, so delete that, pop that, and the top will be decremented here. Then you get this closing curly brace. Now if you look into the stack top, it is the opening square bracket, so they do not match. So here the scanning we should stop the scanning, and we should flag the error that the expression is not good. So as soon as the top of the stack and the closing bracket is a mismatch, we'll stop the scanning and we'll flag the error. And there could be another case. Let us consider this one quickly. Say we have something like this. Let me just delete this. Okay, say we have a plus, and then we are having a closing bracket at the beginning. Now what is going to happen here? We'll have a, we'll ignore this, plus will be ignored, then we have this closing bracket. When you are having this closing parenthesis and the stack is empty, then obviously it's an error situation because you do not have anything to compare with this closing bracket, and that's obviously an error. So if you get a closing bracket and the stack is empty, that's the error condition. Join me in the next lecture where I'm going to just develop an algorithm for this purpose. What we have just discussed in this lecture, we'll put together everything there in the algorithm, and that's going to be a structured algorithm where we'll discuss these things in a much structured way. And in the next to next lecture, we'll convert that algorithm to a C program. Thank you very much for watching.